Okay, the next problem we're going to look at the free body diagram for is going to be 413. And 413's figure is over on the left-hand side here. It says determine the reactions at A and B when A is equal to 0 degrees. And that means that it's going to be horizontal then, okay? When A is equal to 90, vertical. And then when it's 30 degrees, about what you see it right here. Okay, so what that changes is going to be the orientation of the reaction of the roller at B. Okay, so that's what's going to change for each one of these. So we're going to start by doing part A, where alpha is going to be equal to 0. So I'm going to start by drawing our free body diagram as this kind of upside down or sideways L. A is a pin. We've got an applied load of 75, and then B is going to be a roller, but it's going to have A as horizontal or A at 0. So this surface is going to be horizontal. So the reaction at B is going to be perpendicular to that. Okay. So 413. Underneath here. Zoom that. 413. I'm going to put my convention. And I'm going to start for this one, part A. And this part A. It's going to be point A, point B. 75 pounds going down in the middle. I think it was 10 and 10. Okay. And then the distance is 12 from A to the horizontal part. And then now we've got to put our reactions at A and B. Okay. A is that pin. So that one's, I don't know, I always think of that's kind of the easy one. So it's an X and a Y. AY. And I'll show this one going. Sorry. AX. Okay. And then B is that roller. So for part A, it's where alpha is equal to 0 degrees. So that means that the surface is horizontal. Okay, if that surface is horizontal, then the reaction at B is going to be vertical, and I'm going to assume it going up. So we're going to call that BY. Okay. And that's it. So then you're going to solve for those reactions at those two supports, AX, AY, and BY, using your three equations of equilibrium. Okay. Any questions on part A? Okay. Part B, same problem, except the orientation of the surface that B is riding on is going to be vertical. So how this changes is everything else remains the same. So I'm going to draw my A. Over to B. In the middle is the 75. This is 10 inches, 10 inches, 12 inches. My AX and my AY exactly the same as the last part. I'm going to keep those exactly the same. Okay. So I'll just make sure everybody's on the same place. And then my surface here is vertical. Okay, so the surface is vertical like that. So it's kind of like this is the surface that it's riding on. So that means that its reaction is going to be perpendicular to that. So this time at B, that is going to be a horizontal. Okay, so we're going to call it a BX. Any questions on that one? Does that make sense? Okay. So we've got one more. Got one more. The last one is going to be very similar to the orientation that they're showing. So in this case, alpha is going to be equal to 30 degrees. So now this time that is going to be perpendicular to that 30-degree angle. Okay, that's how that's going to change. So same problem. So this is 413, but this is going to be part C. So again, I'm going to have A going over to B. Same free body diagram in terms of 75 coming down. Same distances. Okay. B. My A reactions are going to be the X and the Y because this is still a pin. Make sure you label them. Okay. Now those numbers are going to vary for each one of these, but their orientation is the same. And then because I'm going to kind of draw the surface like this so we can kind of see that. That's my surface. And my force at B is going to be perpendicular to that surface. So this is going to be B. And if we look at this in terms of horizontal, this angle right here is alpha, right? And we know that to be 30 degrees. And then we know that this from here to here is 90 degrees. So that means that this angle is 60. You see that? Because you're going to have to get X and Y components in here. This is going to be a BY. This is going to be a BX. So you're going to have to be able to calculate those, and you're going to need to know like an angle or two of that triangle. Does that make sense to everybody? Okay. So then you're going to want to do that BX and that BY in terms of their B. We've seen that before. And then you'll be solving using those three equations of equilibrium. Okay. All right. So those are the three looks at the free body diagrams for 413. John asked, do we have to draw a free body diagram for each one of the, for each angle? Yes. Yep, you're going to do three separate free body diagrams because it's really a three-part problem. Because AX and AY will be different every time. Okay, those will be different. Because of B changing. So it is three separate problems. So yes, you'll need three separate free body diagrams. All right. Any other questions on that one? Okay, then oh yeah.
They all.
That one, since it's a part A, part B, and part C, because it's a continuation problem, I'll say no, you don't need to. We're going unconventionally for B and C. Any other questions? Okay, all right, then I'll stop the recording.